2x plus 1 equals positive 7, and 2x plus 1 equals negative 7. And then these are just linear equations, so you should be able to get x by itself and solve. So we need to subtract over our 1 and divide by 2. It's okay to have fractions and decimals for answers on these. That can happen. So we get x equals 3 and negative 4. You should always be able to check these. What would I have to do to check them? Plug them into the original. And that's a pretty quick calculation. You know, if you put in 3, 2 times 3 plus 1 is 7, the absolute value of 7 is 7. If I put in negative 4, I get the absolute value of negative 7, which is also 7. Is that one okay?
Bill is Friday.
Thank you, Friday.
All right, so next one. When I look at this, how is it different?
There's a negative, not read negative 3.
Okay, you have to have the absolute value by itself first. So before I set it, make two separate equations, I need to divide by negative 3. So we get the absolute value of 4x plus 5 equals 5. So then we make two equations. 4x plus 5 equals 5, and 4x plus 5 equals negative 5. So subtract over the 5, divide by 4, we get 0. Negative 5 halves, or negative 2.5. Question. Again, you can check these just by plugging them back into the original. C. What would we need to do?
Subtract plus 6.
Mm-hmm. And then we can divide by 2. So we get the absolute value of x minus 4 equals 9. So we can't solve anything until the x is by its, or the absolute value is by itself. And then at this point, you set it equal to both positive 9 and negative 9 to solve. 2. So if we add over the 4, we get x equals 13 and negative 5. Okay, so what's different about the last one?
There's 2 sets of absolute value.
So the strategy is the same. Isolate the absolute value. Well, we have one on each side. The first equation, we just drop the absolute values, right? So the first equation, nothing changes except we don't have absolute values.
Wait, it wouldn't be positive.
We're just taking away the absolute value. We're not actually calculating it yet. When we did the second equation up here, we set it equal to the opposite, the negative. So what we're going to do, we need the opposite of the entire side. So you make one side negative. And you notice I put parentheses here because what do I need to do with that negative? Distribute it. Okay. So then we just solve these. So if I subtract over my 3x, and subtract over my 1, divide, I get positive 5/8 for the first answer. Second answer, if we distribute, we get negative 3x plus 4. So if we add over the 3x and subtract over the 1, divide, we get negative 3/2. And again, if we wanted to, all we have to do to check them is plug them back into the original. So even if the absolute value is on both sides, the strategy is the same. Just make sure when you do the negative, you distribute it through the entire side. Don't just put a negative in front. Are we okay with the absolute value equations here? So let's start looking at some inequalities. So yesterday we had our rules. We wrote down a rule for less than and a rule for greater than. And we talked about great or less than. So in this case, I have greater than. So that means it is an or statement. So for the ors, we do two separate inequalities. The first one, we just drop the absolute value. Bless you. The second one, you flip the inequality and make it negative. So this is either greater than positive 8 or less than negative 8. So then if we want to solve, we subtract over, we add over the 4. Divide by 2. So a is greater than or equal to 6. This one we add over the 4. Divide by 2. You don't have to draw a number line, but if you're not sure what your answer means, we could kind of use that to help us. Greater than or equal to 6 is everything 6 and larger. Less than or equal to negative 2 is everything smaller than negative 2. Just like we've done with everything else, I want interval notation. So if you come from left to right, this is coming from negative infinity. Stopping at negative 2, had an equal to, so that's a bracket. Or we put a union symbol, just a U in the middle. This one starts at 6 and goes to infinity. When your original statement is an or, so a greater than, you should expect to get two pieces like this, because most of the time, and I'll show you the one case where it isn't this way, you have two separates, everything smaller and everything bigger.
Is there a way you could say it's everything but negative 2 to 6?
No, that's because the question isn't what answers can it not be, it's what answers work. So you need to write it like that. Other questions?
Could you do a is less than or equal to negative 2 or a is greater than or equal to 6?
Technically it's the same thing, but on all my directions I will say write it in interval notation. So I will want this last step. Other questions? Okay. So for B, what do we have to do before we do anything else on this problem? Right, you have to get your absolute value by itself, even before you decide if it's an and or an or statement. So if I subtract my 6, okay, so this is a less than. Is that and or? So how did I tell you we could set up the ands? we just made one big inequality and we put it in between the negative and the positive. So we say -6 is less than 3b minus 1 is less than 6. You could make two separate ones, but I think this is a little bit easier when we get to our final answer in deciding what to write. So if we solve this, we need to add 1 to everything. So -5 is less than 3b is less than 7. Divide by 3, so -5/3 is less than b is less than 7/3. You don't have to make a number line, but I'm going to do it just to illustrate what's happening. It says that my b is larger than -5/3 and smaller than 7/3. So my answer here is just everything between those two numbers. So the interval is -5/3, 7/3, and it gets parentheses because there was no equal to.
Would the ends always be like that?
Yes. So ors, we're always going to get two pieces. Ands is just going to be everything between the two numbers. All right. C, what's my first step? After 3. And then? And when I divide by a negative, what happens? Flips it. So we get 19. Okay, so right now, this is the point where I decide if it's an and or an or, once I have my absolute value by itself. So which one is this? And, less than, and. So we know we should get just one interval for our answer. So we put it in between the negative and the positive. So if we subtract 2 from everything, we get -29/5 is less than x is less than 9/5.
You would be fine with decimals.
Yeah, because you wouldn't have to round them, so it'd be okay. So again, this was a less than, so an and, we're just expecting everything in between two numbers. If you did look at a graph, it's saying your x is bigger than this and smaller than this. So it's just the interval -29/5, +9/5. So anytime the original has an inequality, you need to be giving me an interval in your answer. D, matter 2. Then I have to ask myself, is this and or? Or, great or. So we should have two separate pieces. So the first piece, you just take away the absolute value. Or for the second piece, what do you do?
Flip the sign, which from bad negative or do the opposite.
Yep. Flip the inequality and make it a negative, so less than -9. Okay. So solve each of them. Subtract our 4. What happens when I divide by a negative? So we get x is less than or equal to -5/3. This one, when I subtract my 4, I get a -13. Divide by -3, so flip it. So greater than or equal to 13. So again, number line optional. It was an or, so we expect these to be going two separate directions. Less than or equal to, so equal to means bracket, the 5/3 greater than or equal to 13/3. So it would be negative infinity to negative 5/3, bracket, union, bracket, 13/3 to infinity. Any questions there? Last thing I want to look at. Why?
Because the absolute value can't equal a negative.
Okay, if you look at this first one, we have the absolute value equals a negative number. We said yesterday absolute value is distance from 0, and that distance always has to be positive. So if you caught that, if you noticed at the beginning you had the absolute value equal to a negative, you could stop and say no solution. If you didn't catch that, you would solve it, but when you went to check it, it wouldn't work. Okay, so anytime you have the absolute value by itself and this is a negative over here, you need to stop and think about what that means.
B is also no solution.
Wrong solution.
No, C is not a solution.
All right, so B, I have an absolute value on one side and a negative on the other. We know that an absolute value is what kind of number?
Positive.
So when is a positive number going to be smaller than negative 5?
Never.
Never. So it's a no solution. Again, if you didn't catch that, you would solve it. Let me just show you what happens if you solve that one. So we always put it in between the negative and the positive. But if you set it up, it's going to look like this that time. Was this an and or an or? And. So we need things to overlap. But what this says is x is bigger than 0 and smaller than negative 10/3. And means they should overlap, do they? No. So we could see that's no solution there as well. Okay, C. Let's stop and think about this one. Again, I have a negative over here. So an absolute value, that's a positive number. When is a positive number bigger than negative 5? Always. No matter what positive number you give me, it's bigger than a negative. So if something is always true, what do we put?
Or negative infinity positive.
If you didn't catch that and you tried to solve it, is this an and or an or? Okay. So you would get x to be greater than negative 10/3, or x to be smaller than 0. Or takes everything that gets shaded. So greater than 10/3, smaller than 0, everything that got shaded is the whole number line. But if you pay attention, if you have negatives after you get your absolute value by itself, you really don't have to work it out. It's going to be one of two things, either no solution or negative infinity to positive infinity. And you just have to pay attention to the problem to figure out which. Any questions?
I think so.
How about hand?